Welcome. So chat is still empty. Let's see if this will fix itself. So today camera is working. It wasn't working the last time. So if you watch this later, this is part 2 of my OBScene series, OBScene being my new tool. I will explain or repeat what it is. In the description to this video, you will find links to my GitHub repo and to the part 1 where we set up everything. So I will start by looking up what worked last time and where we left, and then we'll see today. I will show some more stuff. I will work on that and let's see how it works. So let me switch over my screen. So now, as I said, we will have a picture today, which is great. So what's going on? I had this explained the last time, so I changed some stuff here, which means we today want to look into cleaning up the source code a little bit. Also, object-oriented programming comes into play, so we think about how we can make this happening and stuff. Explanations will go in, like IDisposable, we will use that, and we already saw that, even if you guys didn't see that correctly. Let's see, so we have class design to talk about, maybe storing and loading the scenes, probably not this, not reacting. I don't think we will make it today. Not making it too long, having fun, just a little bit of coding. That's what I basically want to do today. Hope sound is good. Hope that picture is also good. Let me check everything. Yeah, chat is still empty. Probably, I was also thinking about when to record. Now it's, as you can see down there, it's 3 p.m. now, my time zone. And I was thinking maybe on Sunday, this is a good point in time where people want to look, but obviously no, they don't want to. So I try to figure out when you guys want to join on these things. Last time it was 8 p.m. There were more people there, but let's see how it evolves. We will see. Okay. Anyways, then we have the recording going on and so on. So let's quickly go to the repo to look. So we have some stuff going on here. This is the source code. We have a logo, and I totally forgot to do stuff. I have to do that today, add some requirements, because I wanted to add Windows as a requirement, and I forgot to do that. And then we will do some more stuff which we forgot last time. So let's hop over and do actual coding. So let's go and go to my folder, which is OBScene. Here you go. It shouldn't have anything going on. That's nice. Let me quickly create a local branch, git branch, git checkout, so that we are not working with the main branch the whole time. So we can go back. If we screw up something, we can go back. So I want to show this as well. -b, which will be, let's do it day 2. So why not? So we're on day 2. All is good. So let's open up OBScene. By the way, I just see there is or was one viewer. What do you think? Do you want to see me doing it in Writer or in Visual Studio? If you want to, just write it down in the chat. If you like to. I don't know. I have Writer in place and Visual Studio. So any opinions on that? Let me wait a little bit. So, I don't know. Do you want something? Are you not caring? So if you don't say anything on that, I will probably do it then in Visual Studio again. So as I said, we have an SLNX here, and let's start this thing. So the one thing that we last time we had this yellow marker here, which was because we are using, in our concept, we are using a lot of Windows API stuff. So this is going to be refactored today. So you will see some refactoring here. And in order to use this, you have to tell the project, and we did it with this thing, and I don't like it at all. You have to tell it, hey, listen, we only support Windows, but this is clumsy here. And last time I was searching for a way to do it here in this file, and I tried to do it this way, and I figured out, as promised, that there is a better way to do it. Let me copy this in. So instead of this, when you just put in this stuff, like supported OS platform version, the maximum is 7. So I'm guessing this is, I don't know, Windows 11 or whatever. I could do 6 to support Windows 10 as well. Let's do 6. Let's try. And then target platform identifier is just Windows. If I do this, I basically can remove this line, I think. So that's all that's left. And I can clean it up, and now this is my startup method, literally, right? This is all it needs. Let's see if it builds. I want to try to, if that builds. It builds totally. Let's see if it runs. Let's just run it and see if a red circle appears. There it is. This is the thing. I will explain in a minute what this project is about, but I'm drawing a red circle here. That's what it is. And if I hit enter, it disappears and the project is done. So that's the situation that we got to. So if you didn't see the first part, I prepared some images, which so first of all, using Windows config in CSproj now. So that's what we can commit. So we are committed this is nice, nicely done. So also what's interesting, I have this README, and I was thinking about maybe I open it in code to have more room. So this README here, and what I have prepped, let's see if I can do that. Let's do the preview. This is a preview. No thanks, no server. Testing, OBScene requirements. So let's do, first of all, the other requirement. Let's add it here. OBScene only runs on Windows. So that's the next requirement. So let's have it here. That's nice. Okay, next thing, let's add some, what is that? OBScene, then we have to do this to have level 2. And let's do the idea. So, and the typo. Screen. So is that what I said? I think yes. Okay, cool. Idea. So like a summary here. So the idea is, as a creator, I don't see the same as my viewers when sharing my screen. Here are some, is an example of this. So let's see, if I put in, for that, if I put in an image, which is what my viewers see and what I see. So this is the image, and let's put in, I don't know if this is a good idea. Wait a minute. So that is what I wanted to do. Yeah, that is not a good idea. So what we need to do here, I think we need to go to the image source. There you go. And then we have to tell it the style with width, probably 20%, something like that. Better. And then I should close the tag. And then what I can add here is another image, which will be, this is a desktop I see, and on top what you guys would see. This is my example. You guys would see, let's say, YT cam. This is what you see. Okay, so here we go. This is not perfect because the screen ratio is not the same, but anyways, you get the idea. So I prepped this. So now let's label this. What my viewers see. Let's do this. What I see on my screen. So here we go. That's a problem. When OBScene is OBScene, I need to learn, is ready to use, it will show my desktop to me like this. So now we can go and we can say, well, actually, this is mask cam. This is what I want to see. This was desktop. And then instead of this, I have, I think, mask cam. So this is my plan. However, if viewers see this, this is then mask, let's say, right, YT right. I prepped this. Look at this. I think it's a nice explanation. If you see this, I would see me. No, this is, what was it? Mask. So, and so on. So this is my example. So that's the idea, right? This is what I want to achieve. So we are at this point. This is like, this is what you now see, this thing on my stream. But I, at this point, which I'm pointing to, and you cannot see what I'm doing because my mouse disappeared. You see that on the screen? So that's exactly my problem. If I mark something, I want to know that you guys don't see what I'm drawing here. And I drew something and you cannot see that because it's behind my face. That's my problem. And I always fuck up on this. Okay, so now we have it. And then let's do edit, edit screenshots to README. That's my commit. And restart extensions so that it starts yelling, stops yelling at me. So that was that. I just wanted to add this, and let me maybe push this, and I cannot because I have to get, I always forget this command. So from this moment on, for today, what you have on GitHub, guys, you have a new branch. Here it is. And you can simply switch over to day 2 to, come on, day 2 to follow me on that. Now you have this. This is looking bad. Good that I checked it. Let's go back to OBScene and hit some enters, because the GitHub interpreter is a little bit different than, I guess, the one on VS Code. This is fixed markdown line breaks, I think. Commit and push. Let's see if it fixed it. Yeah, this looks better now. And I think it's a pretty good explanation of what OBScene is going to be, right? Okay, nice. So let's go back to code. I think I explained this enough. So let's close this. And now last time we had this concept thingy. And also I wanted to talk a little bit about this, but this is our current code. And let's do better than that, because currently the first thing we need to check is we have everything mixed up. We have kind of the logic together with the program. I hate this a lot, and so on. So let's talk about what the first thing is we need to do. We need to come up with a mental map of how our solution should look. So let's add a new section here, and maybe to pick you guys up what I'm going to do, like the architecture or whatever. This is just a broad idea. Okay, let's go. So I have currently, don't do this. Don't do this to me. Don't do this. Okay. I have currently any form of application. It's currently an UI, so it probably will be an UI. This is the, let's call it the OBScene exe, the executable, whatever. And there is my project. So what I need is definitely, I need some structure, which will be, I need some abstracts. Oh, I hate this tool a lot. Anyways, abstracts, this is what I need. Meaning this is a DLL. So let's color it differently. This is a DLL, which we will need. And then I also will need some logic for WinAPI. So I want to do this. Accessing the Windows API should be its own thing. Currently, it's all mangled up. Look it up. So this is like doing everything. This is able to draw a circle somewhere. Where is it? Draw a circle or something? Demo. This has the actual demo, which is, I just wrote it last time with a lot of stuff. This is not how it should be. What I actually want is all the API stuff, which is here. All this stuff like getting this marshalling, the module handler, whatever. This should be somewhere else, the whole logic. And then I need something like my core logic. So I need something like, I don't know, logic drawing or something like that, which is probably... let's call it core. This is my core logic for my OBScene. So this is how it's going to be. So obviously the project is going to have some, let's call it dependency on this guy. Okay. This guy has some dependency on this guy, which brings them to here and also to that. So this is kind of where I want to be. So I'm separating stuff. My core logic to talk to Windows is here. There and to do my forms, because as you can see now on GitHub, I need different stuff. I need circles and I will need rectangles. Currently, that's the only forms I need, but who knows? Maybe I have different stuff that I need depending on whatever there is. Okay, cool. So that's where I want to end with. And making this happening, we need to be very careful, because if this is a .NET application, but this is using WinAPI stuff, we have unmanaged resources. And what that means is we need to be careful about our memory management and stuff and what we will use. And this is what we slowly will approach to. So let's do this. Let's follow the fan. Let's start with the abstracts. Okay, for this case, I usually tend to add a solution folder, which is just my logic. Every logic in my world means anything which has nothing to do with like UI stuff or APIs or whatever I have. Okay, let's add a new project. And for that, I always, in that logic folder, it's always going to be class library. So let's go there. Be careful about the folder. It needs to be in source logic in my world. I show that in a minute. And then the class library starts with logic.abstracts. Okay, let's call it this way as it was in my drawing. Okay, next. So .NET 10 for sure, create that. So first things first, I remove this guy, the class, I don't need it. And what I will do now, I prepped this last time. I have this file here, the base props, which basically, if I import this file into one of my projects, what will happen, it will inherit all those settings. So it's .NET 10, this, all of that gets inherited. I don't have to repeat myself. So I just simply go here. This is an import line on the current UI. Just take this line, go here, remove all of that and put it in. Number one, because all my projects need to have those things now in place, I just simply remove it here and put it into my base props, because literally most of the projects that I have, oh, actually, do I want to do that? No. That's not good. So because, let's do it here. Let's leave it here. Because in my world, the only projects that need this are this, this, and that. This does not need to tell this assembly, doesn't need to tell to the compiler that it needs only to run on Windows. That's why I put it out. Okay, cool. So I have a new project, Logic Abstracts, and watch. If I now say, okay, let's start as every decent programmer should do in the world of object-oriented with interfaces. So there is an old saying that always program against an interface. It's a good idea. That's why we call it abstractions. And let's say we have an interface which totally makes sense. which is a new item, and this is an interface, and this should be called we can rename it later, but IGeometry. I don't know. It's just my public facing interface. So automatically, because I have resharp in place and Visual Studio does it, you can see that your base props are working because it immediately took this thing as my root namespace, because this is what my base props said. If I now build this, rebuild, let's see if it's working. It's working, no warnings. And I will look into ls, what is it? Source, logic, thanks for the like. Hi, Pasanado 7160, greetings, nice to see you. Okay, so source logic, and then what was it? Logic abstracts. This is my project path. So now you see why I'm doing this in this matter. I want the file structure to match whatever I see in my solution structure. Okay, so this should be in sync. I like that. So now I have a bin folder and I have this folder, and look, all of this is automatically named obscene.logic.abstract, which makes totally sense. On the file name, I don't need my codingfreaks name there on the file name. That's why I'm not doing it. And yeah, this is how I do it. Okay, I have an interface now, which let's do correct here and say must be implemented by all types which are able to which represent forms drawn to the screen, something like that. Okay, so what could be here? It could be that this is something like a void or draw. That's what it is. That could be something draws the form to the screen, or refreshes it. I don't know if we need it this way. Let's see. So this is my interface, IGeometry. What else? Every geometry probably has a position on the screen. So let's see. If the position is something that we need, we already dealt with this because we had this on my, where was that? Where was my draw circle here? And we had this idea, those guys, the sample here, I just copied it from somewhere. I don't know. It has like X, Y as things. I don't want this. I want something like point. I think point is a thing. Point, let's see where we can take it from. Point is in system drawing. I like that. But I think system drawing is not the correct thing. What we really had was we imported system drawing common. I think we need to do that as well. So now something interesting will happen. So by default, I could do this, go over to abstractions, and now I could import this the second time in version 10.08. Okay, so that's what it is. Okay, now it immediately detected something. Let's see, point, and let's give it a property. This is an interface, right? That's why no public is involved. It's just a contract. Point position is probably read-only from the perspective. It should be read-only because resetting the position should be a method. Not sure. Could be, let's try it this way, because from the .NET perspective, so gets or sets the position on the screen. So that is the absolute position on the screen. Okay, cool. That is the thing. And then probably later we need some more, like for circles, we would need a center point, whereas for a radius, sorry, whereas for rectangles we need 2 dimensions and so on. Let's start with that. So now comes an interesting point before we proceed. The current situation allows us, from the .NET perspective, to have different versions of the same NuGet package in those two projects, right? So let me show what I mean. Let's open this guy, pin it, and let's open this guy, pin it as well, and let's do move taproot right. So that's what it is. So those are the two CS project files, and now in both files we're referencing the version, and without any problem we could say different versions here, which we probably never want. We want only those versions. Plus, when we do NuGet operation, it always needs to look, the NuGet thing needs to look in two places. So turns out there's a new technology in place. New, it's not even new, it's 2 years old or something like that. And I have a video about that. If you want to learn more, let's go to my channel and let's look at this. I'm not going to show the video, just to point it out to you guys that you can look it up. This is CPM, something like that. There it is. There's a video, you can totally watch this, and you even have my face there. Let's zoom to 100. So this was about NuGet Central Package Management. When was it? It's pretty old, and you can totally look it up. And it explains what I will do now, because I also created a tool for that, which is Git, I think on my company account, not sure. Is it CPM? I think I did it on my company. Yeah, .NET to CPM. What I did, I created a .NET tool. Somebody wants JetBrains Writer. Yeah, I get it. So I will do Writer, no problem. Let me quickly close this and let's hop over to Writer. Sorry for being so late. Writer OBScene SLNX. Let's open up Writer. So if you want it, you get it. So same project in Writer. Totally get it. So here we go. I hope you like it. Now it's Writer. Here we go. So let's hop over now. Don't ask again. Okay, cool. Back to CPM. So I have this one in place, and there's this project on GitHub. This is my dev tier. Let me put this in the chat here so that you guys can see it if you want. So you can totally do that and install it. It shows how to install it. .NET tool install -g dev tier tools to CPM. I already have it on my machine. I show you how to test, and then you have the to CPM verb available. What this does, let me show you now. We have a perfect example. So before we do this, let's add a commit. Thank you. I like that you like it. So added abstractions to solution. Okay, this is what I did. Let's have a simple commit so that you actually can see what's going on. Let's keep it open and let's see. .NET tool list -g, here it is, and this is my tool, right? Dev tier is the name of my company where I work, and this is my tool. Okay, so what you can do now is you can call to CPM execute dot meaning in this folder, wherever. So you need to do that wherever your solution is situated at, so in your root usually. So if you do this, what I will do is I will summarize, look up your project files, and I will detect that in both files currently there's the same thing. Even if there would have been like multiple packages, it would just detect them and so on, and then it asks you if you want to do it now. Let's say yes, and it says that it created this file, and not even only that, it added the two files, and let's look up the changes. So here we go. Now we have those changes. So the unversioned file is, let's put it into versioned. So here we go. He added this file, which means now two things. First of all, it said we want to use central package management in this solution, number one. Number two, it said that, hey, this is a package version, which is different than it was before, of system drawing common. Some packages in this solution need this thing, but it's stored centrally on the solution level. So let me add this existing new file, Now this is this file. Let me add it to the solution. So it's stored at the root. Here it is. So now we can see it in the solution. Great. So now what will happen is on every NuGet operation, he will, when you look up here, like this here, why is not showing? So it removed the version from the actual project. So now we have the version in one single place, in one central place, right? So, and this is great because all the operations for CPM, for NuGet are also sped up because NuGet understands, wait a minute, I don't have to check every file. I can do it here. So that is way better, if you ask me, than having those versions spread all over the place. Let's add this and say switch to NuGet CPM. So let's commit this as well. And it should work. If I rebuild my projects, I'm doing it right now. It totally should work. It builded it. And let's see if we still can run it. Let's debug the project. Is it working from Rider? I hope so. In theory, it should work. And draw a circle. It's not looking, no. Right, so there's my circle. We don't need this totally. And if I hit enter, circle disappears. Great stuff. So it works. That's good. So we are good to go ahead. Let's go back here to my folder view. And I'm not even sure if I want this to be in place. Maybe, but this can go down. Okay, let's so bring some order on my screen, right? Let me drink some coffee here. Okay, guys. So now, with this in place, what I want to do, I want to create my second logic project, which is like new project. And this is in, again, source logic. And now it's repetition, right? So this is logic.WinAPI, let's say. Why not? This is a WinAPI logic, right? Create. So I will do this, remove the class, and it's, by the way, red because it's unversioned. That's what this thing is doing to me all the time. So now I have this in place. In this project, I will re-add, okay, project files with SimuClick. So now I import this as well. Let's put this in. And in this property group, because now I have a WinAPI project as well, I need to copy in this stuff so that the DLL, I think I need to, also knows that it's only supported on Windows, right? So let's see. This is what I do. And I think I'm not sure if this needs the NuGet package. And then I can look into my concept and now I can think about what should be moved over. So what we should see is that how could that work? Can I do that? So basically what I want to do is I want demo. This is my static void demo. And what I need to expose is like the whole stuff. It was, okay, so blah, blah, blah. And then let's add a class, which is, let's add a class, how to name it, drawing helper, which, don't ask again. Let's add this. And you know what? I think this will be a static class because it's better to have it. Somehow my color scheme is out of the window. I think for now it's okay. I'm not going to mess around. Okay, provides helper methods to draw stuff using the Windows API. That's what it does. So at this point in time, let's do number one. Let's put this out and put it here. So this is how it starts. Next thing is demo. No, we will add the DLL imports, a lot of stuff. We have a lot of stuff going on and we're just copy it over first things here. Let's see if it works. Unmanaged pointer. What is it needing? Use unmanaged pointer. That's interesting. Struct layout and so on. So what's breaking here? Oh, the regions. Yeah, I have some regions here, probably here as well. So I like regions. Ah, bitmap. So here we go. this needs to draw a circle, meaning it also needs the NuGet package. But what I can do now is, thanks for Pasanaro. Yeah, the abstraction is very important. You're totally right, I think. So that's why I'm going to slowly, but correctly, right? So this is my goal. So all I need to do now is add the package reference without any version, because the version is defined, as I said, in my central package management. I just save this file, brings in the thingy, and now it should ask me, here we go, if it should import the missing references. Here we go. So a lot of stuff is hard-coded here, which is not good. Let me reformat the code. So here we go. We have a lot of warnings. Not sure where it comes from, probably naming warnings. And I got rid of those, I think, in the concept by telling resharper with this thing, this command. Let's do this as well here. To, you know what, ignore for the moment the naming issues that we have. Because this is normal naming stuff when you deal with Windows API, to be as close as possible to the real API. Okay, so with this in place, we now have stuff, right? We're not sure how to handle this in the right way. We will do in a second how to split it up, because I still think this is not perfect, but we have a draw circle method, which obviously is not perfect, right? It's doing it whatever. It takes in a pointer, which is interesting. And the pointer itself in my demo was created by my demo method. Let's see, draw circle. No, that's not what it is. Where's my demo method? Where is demo? Here. So the demo method actually draws the circle, right? So what it does, it create window X. This is where the handle comes from. And we need to do stuff, and it registers this, and it ensures to deregister it again. Well, all of this needs to be put into my abstracts later, which we started here with an interface. And yeah, we will see how to do that. Okay, so but for the moment, the question is, if I now have demo as the only method, can I, in any case, remove now this stuff, which I copied over, only leave demo, so that would be my first iteration, right? Only leave demo in place, remove all the other stuff because we moved it. So he's not happy. Because we need a dependency here, let's do that on WinAPI currently. Let's do that. And then what we need is we have drawing helper, which probably needs to expose, yeah, you're right, import. So this thing is private. Okay, we need public here. What else? We need public on get module handle currently. This is public. Okay, and probably I think everything should be replace public static, private static, which is not going to last. This is not the right abstraction, but we want to do step by step, right? So now let's see what he says. So drawing helper here. Drawing helper, interesting. That is that. Drawing helper dot, that works. That works. So that's not going to function because what's going on? Private const needs to be public const. Let's see. Replace all. Is that nice? I think yes. He likes it. So let's put in like first iteration, right? So don't take it too serious. This is gonna be different in pointer 0. Then we have a draw circle method, and we have a show window method, and we have this. Okay, that's kind of interesting. Size of this VND class X. What is that? This is probably ref private struct. So let's do also, I'm not sure, public struct. And again, not perfect, but possible probably. So this is drawing helper dot. Not good, because it's obviously nothing which should be exposed. And then what else? What was it? Where was it? Failing. Class name X, HMD, drawback. Okay, so what is going on here? What is his issue? This is public static VND-proc, SVND-proc. Where's SVND-proc? This is this. What is going on? Do we have something private here? We have this guy private, probably should be public. And it solved it. So everything should be public here. That would be the easy fix. So he says now screen X. Yeah, I know. I totally know. So all we need to do is now to expose something like point in this one, which is position, and demo, let's say size, which is another thing, size. So what we will do is position X. Oh, can you go away? The shortcut is not always working that way. Position.y, size.width, and size.height. So that makes no sense currently, but anyways, let's do a good reformatting on both types. So we have green here, green on this check, green on that check. That's already a good sign. And now let's see what program is saying, because program says concept demo, where's demo here, needs point and so on. So what we did in the concept before was to give it, I think, a static size. We had this somewhere. I think we can remove that. Where is it? CW, we had some static variables here. Where was that? Here. We had a 200, 100, 100. So I think we totally can remove this for the moment. So it's 200 and 100, 100. Let's do this. So demo, which will be demo. First thing is a callback. We talk about this in a second. And then he wants a new point, 100, 100. With, what was the radius, the size, new size, 200, 200. Was it this way or other way around? It makes no sense, right? Like 200, 200 and size of 100, I think. So let's see. Unintentional. So what else? So now he says, yeah, remove this. And then we have draw a circle. We have give it a point, position, a radius, and a color. So that's better. So here, position, position X and position Y, pixel format and so on. Then we have position X, position Y, something like that. We have, no, that was not position. This was size width. Ah, yeah. Size, no, radius, I think, and radius on a circle. Oh, what's going on? Radius, same here. Radius -3 for whatever reason. I think it is the border, like so that you can see that. That's nice. So then we have the alpha. Let's go from RGB. This is like, what is that? It's an int, yeah. And it should be maybe color, and then no, color is bad. Let's do, is there a color? Color is a struct color. So now question, do we have an override which takes a color? Yeah, we have. We can have a color and an optional alpha, which is like the transparency. I think it's clearer, equals to 100 by default. So what we can say is color transparency. Is that a thing or the other way around? Transparency and then color. Probably. So here we go. We have this. Then we have alpha. Okay, so that means transparency divided by 2, whatever that means. And I think, what was it? 120. This is, what is that? Transparency times 2, and this is another color. So what we can say is, let's do this. Yeah, color. What is that? This is called stroke color equals null, and then this is fill color. So we get clearer and clearer, and then we say if stroke color not null, then draw a stroke, which is not perfect. And this is going to be the stroke color. Is he fine with this? Transparency times 2, it's a pen. What is it? From RGB, this needs to be transparency divided by 2 and the stroke color value. Yeah, stroke color value and then 2f. This would be the stroke thickness. We're not taking this now. Radius times, okay, so this is then radius and radius. I hope you still have fun, guys. I'm not sure. If I lose you, probably I lose you. I don't know. Then this is, we don't need this point. We just, maybe we need it. Position X and position Y, which is just a translation. Blend per pixel alpha drives transparency. Not sure what this is, and I think it's okay. So we have now this method, but now the concept is missing the thing. Draw a circle now needs something, and we pass in position size. Okay, let's do it. Position. What is the next? The radius, right? Yeah. Size. Let's take the width and ignore the height. And then what's going on? He says draw circle is 6, but radius color. We need the color. Okay, cool. Color. Red, dark red, that's what we do. And then the optional thing is transparency, which is 50. Not sure. And color red. I'm not sure what's going to happen. So this is probably the other way around, red and dark red, border color. So here we go. I think even smarter would be to put this out, draw a circle in the concept. Yeah, but anyway, let's try it out. Let's see, building, and let's see what happens. So we have no warnings, which is, first of all, a good sign. Let's execute it and see if we still get a circle. Yes, there it is. There's the circle. I know it's hard to see, but anyways. Great stuff, guys. So what is the gain here? The first gain is we, looking into our concept, this is now the demo, right? Which we actually still use, but we got rid of everything. So now what we should do, having this drawing helper out, all is public and so on, I have to think a lot here. So now what I would like to have is, I would have here like the get windows handle method. So I don't like that at all. This is a draw circle method and it needs a lot of stuff. First of all, I think I need to move this a little bit down. I'm not even sure if this is, it's not good. A little bit down. Is it doing it back up? Yeah, ReSharper is bringing it in. Okay, so what I want is on WinAPI, I want this stuff needs to go out for sure. This needs to go out. So we have some constant values. Let's do the next iteration. Okay, let's do the next. So I need a new class, and this is like constants. Public static, because it will be a static type. So let's take out all those constants. 2 constants. Here we go. Let's do this. Drawing helper is not happy. There's another thing, which is, what is that? That's a delegate, which is going to this guy. What is this? Public static in PTR. This is what it is. WND proc. And it needs to have a delegate. What is WND? This is unmanaged function pointer. Oh, it needs a pointer to, oh, that's what it is. So, okay. Let's do that. Add class delegates. Not sure if let's do this. Bring everything. This is delegates. Let's do it here. And let's put this in. So here we go. And then this one is import reference. This is delegates dot. That's good. So this also is a constant, which means let's put it to constants. And let's say this is WND proc, and WND proc with this method, this is the pointer, and this is like, this is actually VM destroy. This is constants. VM destroy. Okay, so what this means is this needs to be, what is this? This is interesting because this is just a function. And what this is we do a new class, WinAPI helper. And this time we make this internal static. You will see why. Internal static, we put this in WinAPI helper. This is a public method. Post quit message, all the other stuff needs to go here. And what we also will do in a second, so where is this? All of this stuff goes into WinAPI helper. Here we go. Those guys. We need to, this is public. This is going to be import. All is good. Then we have more to put in, like those guys. Static extern, all of this needs to go to the WinAPI helper as well. So here we go. So now we have some problems because, let's see what we got. Guys, this is a lot of stuff, but in a minute you will see this clearing up. Bear with me, okay? Yeah, thanks, Andre. Welcome. Thanks, I will have fun. So now those are structs, right? So which means those are types I'm defining. What I don't like is types in classes. So what I want to have is like this is API types, a new folder. And let me add the first one, which is the point. Let's name it exactly as I named the other one, point CS. Let's go to the drawing helper and say, okay, that is what you are. You are this thing, import. Okay, that's what you are. You are a point, public struct point. You will see how we can leverage this. And now we can copy this with size and so on. So let's go. The next thing, let's close some stuff here, to be honest. We have a lot of bugs, I know. This was my drawing helper, and now go from here. So we have size is the next one. So copy this, name it size, go here, copy this out and replace it here. I need to be a little bit careful because that's what it is. Next one is blend function. Blend function. So let's go to drawing helper, cut this out, and do it here. So most of the times, okay, hi Andre. So Ryder in the chat, I don't know if you see the history, like there was one guy I was asking, okay, let's react to the chat. The Sandish X, hey Sandish, look up in the description, you will see link to the repo. You can look up in the repo, be sure just to look up, when you go to the repo, to select this branch. On the repo link, here it is. Just select it and then look up here and you will see what I'm up for, what I'm going to create. This is from the last time. This is also the second part. Andre, to react to you, there was the wish to use Rider today instead of Visual Studio. That's why I switched to Rider, because one of you guys wanted to see Rider. So I did it. Also the message, it doesn't really matter. Okay, nice. Thanks for the reaction, guys. So where was I? So now we have blend function is in. Did I do blend function? I did blend function. So let's go on. Next one, WND class X. Like WND class X. Let's copy this. WND class, what was it? X or X? I think this. Yeah. So let's take this in. Here we go. Should be this. There you go. So next one is, last one is MSG. You see, now it clears. So we can totally say MSG. I'm not sure if we need MSG. We will see that everything that's not needed, aka does not have anything here. So let's do this. And now we have MSG. So we have all the API types now here, which leaves us with a pretty empty drawing helper, which has only one method, draw circle, which doesn't work currently because it needs to go and say WinAPI helper dot. So that's what we need to add before all of this. That's where we moved it. So this is a using import missing reference. Here we go. And then we have probably constants here, constants dot write, constants dot, also nice, constants dot, so everything kicks in now. This is the API helper, this is the API helper, this is the API helper, this as well, this as well. So moving everything out, so some stuff is missing. Let's do this. What else? The ref argument doesn't match parameter type. I totally get you. What happened? So we have an WinAPI with a ref, which is now not working. Okay, ref PT distance. PT distance is a new point that we created. Ref this. What's going on? WinAPI helper. Oh, something is off here. Is that off? Ref this, ref this. Should match. What is going on? The next one is a ref. Wait a minute. Do we have... What happened? What happened? To point. Change the type of parameter of called method to point. What? Drawing helper point. Oh, wait a minute. I know why. We have messed up this. And I think we need to... I'm not sure what, but look it up. The point here is the... What is this point? This is the right one. Something is off with the things. Let's see. This is point and it comes from us. codingfreaks point. This is this. But this guy is not taking... it says drawing helper point. No. This is going to be point, size, point, this. And where are those coming from? Those are coming from the reference file. That's good. And this is also not this. Yeah, this was, we moved it out. What else? One more. One more. Cannot resolve MSG. Correct. Here you go. This is then also done. I hope so. Constants is kind of weird. Yeah, and this is WND proc is WinAPI helper WND proc, which should be just fine. Oh, guys, I like that. I like that a lot. So concept now is not happy. Our concept is not working because it says demo and it says drawing helper. No, this is whatever it is. It is, wait a minute, is draw circle. Yeah, this is this. Okay, I got you. I got you. This would be WinAPI. Yeah, but this is internal, right? This is an internal class and now it's gone. Great. So this is provides internal access to Win32 API functions. So this is what this does. Drawing helper, not sure what you do. Yeah, that's what you do. Delegates to provides access. No, this is a delegate, and this is what it is. Yeah, provides access to delegates usually. So we can do this in remarks. Usually in Win32, this is representing pointers. I think that's what usually is there. That's good. Constants. This internal access to WinAPI constants. So if this is going to be the case, we should call it WinAPI constants. Because if it's WinAPI helper, then we have WinAPI constants. Okay, so here we go. But now we have a problem because we made it internal now from outside. And again, we don't want from outside to know all these details that you need a drawing helper, blah, blah, blah. We don't want this, okay? So what we want to do, the demo thing should actually just say, draw a circle kind of this way. This is the only method I want to have, and then all the other stuff should be there. So let's see how this happens. So first of all, what we need here is, look, the only thing why we call all of this stuff is the HWND and the class name Z, this one, so that we can free the resource. So in other words, what we want to have is, we want this whole thing, all of that needs to go out, the try catch and all of it needs to go out and prep everything for us and return us, if you want to, a type which holds the Windows handle and the registration, the window registration. That's what we need. So let's go and say drawing helper. Let's do a static one and let's say, okay, listen. Public static, and we don't know what the resource type is, object it needs to be, initialize window. Okay, so that's what it is. It takes literally nothing. And this is what we need. So now let's go to my concept and say, okay, what was it? We have this. Let's take everything out, besides the finally. What we need is this. This is not good, because, you know what, actually, we don't need this, the try catch. If it fails, it fails. So we need some types, Control Z, Control Z. We need some types, and then we have WinAPI helper, this one, probably, constants. Is that what it is? No, this is, wait a minute. Oh, this is an API type. This is this. Then we have delegates. Was that delegates dot? No, SWND. What was it? WinAPI? Where's SWND? The heck? Was it delegates? I'm feeling like this is no, this is this. Where is SW? Here it is. WinAPI constants. Not sure. Yeah, it's a WinAPI constants. Okay. WinAPI constants dot. That's nice. So this is this. Okay, so next one. This is WinAPI helper. WinAPI helper. This is constants. WinAPI constants dot this, or that. This is constants probably. This is now interesting. Initialize window. So he's getting this, and so we need to pass him in the point again with the position and the size. Here we go. He needs it. Draw a circle is not going to happen here. And then we need another method, which is public static void show window. Here, this is WinAPI helper show window. That's going to happen. And then the drawback, where's the drawback? Where is this? Draw callback. Where's the draw callback coming from? Wait, this was my code. I don't need it anymore. Yeah, I know. If in pointer 0, this is not going to happen. Throw, where was it? Throw new invalid operation exception. While I'm doing this, let me explain you guys that what you never should do, you should never throw something like application exception or something like that. Don't do that. So the thing is here, we need to return something like, and now we need this one. We need to return the class name, which is just, this is a bad name. Class name is this. And we need a handle. This is a result. Close. Result. And then what we need is a new type, which is in the, is it in the abstractions? Let's put it into the abstractions. Good thing. We call this models. And then what this is, we have an int pointer. Not sure. Do we want it here? Let's put it here. We will see. Let's put models here as well. So this is a class which should be the I am in the method draw circle initialize window. So window information, which is a struct probably. And this is going to be prop int ptr handle, which is this. And I think, was it a string? What was this? Class name is a string, right? No, nint. Interesting. It's an nint class name. Interesting, whatever an nint is, I don't know. Let's see, can we expose this? Yeah. Class name. So that's what we do. If you have something like that, we need to initialize the property from the constructor. And this is now called an immutable type. Immutable means you have one instance of this type and you can initialize it in the constructor, but nowhere else. If you want to change a value, what you need to do is you need to create a new instance. You can never change it here, which is good. So what we now do is, this is our return type, which is called window information, which comes in handy later. Return new window information. And what it needs is, it needs the handle, so the result, and it needs the class name, which should be great. And now we get it back. This is what we get back. Okay, this is initialize window. So now in our concept, what we need to do is, window equals what is this? Drawing helper, initialize window, position and size, that's what it is. Then we say this is draw a circle. I think draw a circle can, we will see. Window dot handle, which is great. Then show window, this is drawback invoke, that's good, we will do better than that. And then we will do, let's do try here because I don't trust this guy. Okay, this one can be done by draw a circle now. So draw a circle now will need to call show window. WinAPI update layer. So show window is, we have this method here, show window. And what we need is, when do we need to draw it? When draw circle is done, right? Finally, this is this. Update layer. And then, yeah, that is my problem. This needs to go away. So this is public static cleanup window. It needs only, yeah, it needs, again, the window information, window info that we static void. Here we go. And what we will do is we will do this here. So what's unknown? memdc. What does memdc? What the heck is going on? Old bitmap is never used. Old bitmap. Select object, H bitmap. What is going on? Ah, come on. Draw a circle. So it is going on. And then the old bitmap is 0. Selecting the object of memdc. Memdc is interesting. Create compatible DC. I think we need the memdc as well. Update layered window. And then release DC. Screen DC. Here we go. We need all kinds of stuff. So this is drawing a circle. That's interesting. And then what it needs to do in order to release, draw circle needs to return something. This is, what is this? Geometry information, which we need to do. Finally, there's no finally and there's no try. There is just this and just throw exceptions like you want. And now what we need everything that this guy, the cleanup window needs. So WinAPI update. This is probably show window HWND. This is what it's going to be. And then return new. Let's put it in. And then we give it a type. This is, it needs, where's my cleanup method? Guys, here, cleanup window. We need the window, let's give it the window information equals, where was the window information? Draw a circle. Okay, we give it the handle. We don't have it. Handle equals this. Then we give it the screen DC equals screen DC. Then we give it the memory DC, whatever DC is. I'm not sure. We will find it out. We give it the bitmap is H bitmap. And whatever old bitmap is old bitmap. And then we have everything in place. So we will call this geometry information. So here we go. And we need to create this type. So let's see, create type, class, and then add property. What is going on? Create property. I should have done this differently, but anyways, let's create those properties because I think he knows what this is. Those are the pointers. So that's great. Then what we will do is no. Instead of, we will go ahead and tell it to initialize those properties from constructor. A little bit, I'm doing this a little bit stupid. Sorry for this. So here we go. Now we have this geometry information. And now what we can do is we can tell it you will get a geometry information. And what this means when you release, this is info. And this is info.screenDC. Info. That's interesting. Could be 0. Info dot, what was that? What's that? Info, the bitmap. Okay. Info, the bitmap. Then if this is not pointer 0, then, oh, it cannot be null. It can be a 0 pointer. Okay. Then we have the bitmap. We have the old bitmap. We have the memdc. Okay, and then we have the memdc. Okay, that is it. So now we should add a new type, which is a model called geometry information. And what we will do, we will take this, put it in. So now, this drawing helper says new geometry information, which is HM this, then that, then that, then that, then that. This is returned. Nice stuff. It has some warnings, but anyways, so our concept now says var info equals drawing helper draw a circle. Finally, we will say drawing helper cleanup window info. I think this is great. Okay, let's see. Is the circle drawn? There is a circle. Here it is. And it's removed. This is not bad at all, guys. So now we need to clean up this again, so that in order so that you guys can do. I'm not sure about this. Let's keep it very, very easy here. So let's see what we have. Abstract is cool. So we have models. So what is this? Transports pointers which are generated during drawing of forms with WinAPI. In order to be able to later pass those pointers for cleanup or redrawing, probably. Let's see, I'm not sure. This is what this is. This is the default constructor, and there is only one. The remarks is this type is immutable. Okay, see you, Andre. Thanks for giving a heads up. See you later. So this type is immutable. I always do that so that people understand. Oh, so you need to understand obviously what immutable means. I get that, but you know what I mean. So this type is immutable. Nice one. So we need to the handle to the window instance. This is what this is. And now we put this in here as well. So that's easy. The screen DC. What is DC? Device context? I think. Yeah, screen device context, and let's rename this to memory device context, hoping that this is yeah, the pointer, no, the handle is to the screen device. I think that's what it is. The handle to the, I'm not sure what this is. To the memory, I'm not sure. the handle to access the bitmap, and I think the stored old bitmap. I'm not sure, because I think it has to do with the fact that if you redraw this thing, if you move it or whatever later, we are not able to move it. Let me concentrate. It means, like in graphics, you always say, okay, I drew this over an area. Whatever was beneath this area could be the old bitmap pointer, the structure, so that when you move it, you have a smooth reappearing of whatever is beneath. I don't know, could be totally wrong, but this is where we start with. Okay, nice guys. So let's go. Memory device context, screen device, the handle of the memory, handle to the memory. I don't even know if this is true. We can look it up in the documentation. And then the handle to the bitmap, whatever that means. And then the handle to the old one. So that is a nice type. What this brings us, if you don't know, if we use this in the drawing helper, now what this gives you is this here. So you get the description of all the parameters, right? You get this description for the type. Wait, where is it? Including the remarks. This type is immutable. This is what I have written literally, right? So you get a nice documentation in your source code. So we need to do the same. We need to do the same for the window information. So the window information is a little bit different. So the window information is kind of like the geometry information, but simpler. It's also immutable, first of all. Transports information about a window generated by the Windows API. Okay, so this is immutable. This is a default constructor. So this is the handle to identify the created window and the registered class name of the window. And you need to deregister this later and so on. So that's why this is so important. And this is how my types usually look. So I have a nice explanation of everything. That's great, actually. So I think it's great. I'm opinionated, I know. Next thing, we have this. We have some API types, which we need to discover later. So now the drawing helper itself says, okay, draw a circle. So what this is, draws a circle using the given information to the screen. So what it returns, which is the most important, the information to later move or maybe clean up the geometry. So this is what it is, HWD, the handle of the created window. So what we can see, remarks, and we can help out. Use C. What was this? Create. What did we call first? We called, in concept, we called initialize window. This is what we called it. Called initialize window in order to retrieve the HWD. So this is actually a nice thing. So I'm saying, okay, this is the information, but I say, I saw it. They remarks, are the remarks shown? Yeah, this type is immutable. Oh, this is what I wanted. So here, use initialize window in order to retrieve the HWD. Yeah, this is what I wanted. The absolute position on the screen. And I never talked about main screen or not main screen or not main screen. I'm not sure if this even works. How much time are we in now, by the way? 1.5 hours, not bad. the radius of the circle. Come on. The color to fill this circle with. And by the way, I'm not sure if we should put the transparent. Yeah, the transparency of the fill area. And this is optional color for a stroke. Okay, that's what it is. And then what we also need, initialize window. Needs to be called in order to retrieve a valid drawing context for any geometry. So this is the position on the screen. I think that's the initial position because I later could move the geometry, right? Not sure though. We will see. Then we say the size of the window, and then returns the information later needed. That's what it is. Invalid operation exception. This is thrown if no window class could be registered. Here we go. So now what we need is here we need string identifier is, can we do this? GID string identifier. It could be null. But if string is null or empty identifier, what we will do is identify as GeoID new GeoID. So, and then we will use this because I'm guessing that this identifier must be unique on the system. So here we go. This is the identifier, and you know what? I will give it the identifier as well. Window information. Can I add this? Add parameter. That's great. It says identifier, prop string identifier, and I think this is the identifier of the window registration used during generation. There we go. This identifier needs to be set here. And then we do this. So that's great, actually, because now we ensured that the identifier still stays the same. Okay, so let's do this. And then we need to put in this add XML optional identifier for the window registration. UID is generated if this is omitted. Nice hint for outside. So let's generate a unique ID. So we have a lot of stuff. So this is a module handle. This is, what is that? Class name is cool. WinD class X CB size Marshall. I'm not sure what this is. This is a, sounds like a window context. This is register class X create window X. It's actually the handle right there. Let's call it handle everywhere. So that's what it is. Identifier string empty. Not sure what this is. Looks good. This is saying ensures that a window with a given paramref HWD should be called handle is shown. So this is the, what was it called? Oh, handle. Let's copy this over. Could fail. We'll do it. We don't have this. Can we do this? One is show normal. Is that true? Anyways, we can do this later. That is actually, last one is here. Cleans up drawn geometry or drawn window using the provided permref info. So info, the information retrieved by any drawing method. So here we go. Does not look so bad. This is a nice thing. So let's check our demo. This is the entry point, which is bad. This is the concept, and now this is what we left with. This is the whole reason we did it this way. So this is literally what you need to know. You need a window, which is probably better called as a window context. Here we go. This is initialized window. This window context is only here so that you can put it in and give it the handle, which is what you need. At this point in time, our window context, we could optionally give it some my window. Or if I leave it, I get a GUID. That's what it is. Then I invoke the callback, whatever, and no matter what, I clean up the window. That's very important later. That is great, which means in our program, all that's left is this. And this is the preparation for being able to have like the abstract here. This is where we want to add here the abstracts to have everything in place, like, and the logic core. That's nice. So what we will do now, all of this, I know it's a lot, but this is refactoring of WinAPI logic into single project. This is what it is. I can push this to you guys. Let's see. So now what you will have, if you want to see that, you will have the sources here. Day 2. Where's my sources? Actually here. So you, what you can do, oh no, you know what I saw? My, this is why IDEA. I forgot this folder. No, this is this IDEA. This needs to be gone. And then I need to RF. I have a shortcut. IDEA, just remove it. So, and then it should be gone. Yeah, thank you. And then I will remove writer settings from sources. You don't need this. It's not harmful. There's no secrets or something, but this is bad style. So this is what it is. Now this is better. You have your source code here. You have everything here. And what you should be able to do now, you should see the logic project, and it's nicely structured, right guys? So this is what we want. Let me drink something. I really like the current state, because the most important thing for me after those reworks is how does the UI look. So this is simple as it gets currently, and we will even simplify, because my thing is, all that I want to do is I want to draw a circle, a second circle, and another circle, and then I want to clean them up. This is for today a good state of things, I guess. I hope you still have fun, guys. I saw that I lost a lot of you, which is totally fine. It's Sunday. You probably have better things to do. But again, I have the recording here, and I will put some timelines in later. And I hope this is okay for you guys. Let's see. What else? Now, this concept here is, this is what a circle is, right? It draws, but let's look at this. This is basically for every form that we draw. The only difference is that we don't call it circle, maybe, but we call something else. And now the point is, I want to abstract this away. So what needs to be done? So we need, in the interface, we have an IGeometry. This is the description of the geometry. Like this is, or is it? I'm not sure. I'm not sure. Is it? I always struggle with this, to be honest. But what we can do is, if this is going to be IGeometry's iCircle, right? So can I do this? Is this logical? iCircle, let me start. iCircle is IGeometry. It's an interface. We don't need to implement it. And it adds something like prop int radius. Not public. Int radius. The radius of the circle, which is and this is must be implemented by circles. Does this make sense? So this is now the question of interfaces. The thing is, could there be, the interface only makes sense if we have like 2 types of circles, which could be, but then it would be probably an ellipse and not a radius anymore. So no, it does not make sense. So what we do is we should add something like geometries. And then we should add a class which is called circle, right? So that's what we probably do. Okay, listen. So iCircle dies. It simply says, okay, listen, I will add, this is an IGeometry, that's the theory behind it. It adds this, and then I have a public property with the radius, right? This is what it is. Okay, nice. But now I have to implement the whole geometry stuff, which in theory makes not so much sense. What I will have is, I will have another thing, which is base types. So what I will do is base geometry, which is an abstract. Implementing IGeometry. This is what it is. Draw in this. Okay, we have those 2 things. Now it's an IGeometry. And now what I can do is I can inherit from base geometry. And currently I don't need to do anything. So base geometry, on the other hand, can now do something very important. So look at this. So we need a window context, right? For this is what a circle is. So let's put it in. So now comes the big trick with inheritance, guys. So this is a drawing helper. And now the interesting thing is, now we are in abstractions and we would add logic here, which is probably not what we're going to do. Let me add another project. This is what I called logic core. And this is source logic. Okay, so let's do this. Okay, nice. Let's remove this. Let's add probably this to here to add a project reference to abstract and WinAPI. Probably we need both here. This is the whole reason. And now what I can move over this and I can move over this. So this is wrong because it's in the wrong. Yeah. Okay. So what's going on? Drawing helper is import missing reference. What's going on? Draw. What happened? I think this is what happened here. Okay, let's see. Is this working? Why is int an issue? Okay, he is lost all of it. So this is clear. Close all tabs. What did I screw up? This is position size. Okay, this is point. Point needs to come from... What is going on? This is package reference system drawing. Using system drawing common, right? So using system dot... we have some issues going on. So actually, it's still here. Let's remove this for a second. Let's see. Public void draw. It is IGeometry, base geometry. It is void. This is not, he doesn't like it. So what's going on with you? Rebuild, which should not What's going on? Maybe the old, have you tried to reopen it? Come on, just open Writer for me. Writer's not coming up anymore. That's interesting. Writer OBScene. Is this helping? Here we go. Let's see. Is this better now? Because I may have tricked him a little bit too much. Point is unknown to him. I'm not sure. What am I? Oh, wait a minute. Could be that this guy now needs this. Right? Is this your problem? Are you not like... Ah, you see that? Now it's getting better. So point is import missing references. This is great. So we are back in business, guys. Let's go to the concept and let's copy this line. So now we are in base geometry, right? So what we do is we do this. So drawing helper comes from an assembly, but this is then the position of the thing. And what is this? It needs a size. So, okay. So what we're going to do is we will introduce something in the IGeometry, which is a size. Interestingly enough, gets or sets the size on the screen. So that is what it is. Base geometry now needs a size. Here we go. And we can put in the size. You will see how we work on that. So we will do the following. We go ahead and we will take some advantage. This is the new field property that is going to be change position field, no, value. Here we go. I'm not sure if this is okay. Set is this, and can I say this would be field as value? This is a new syntax. Yeah, I can totally omit this. Draw, which is good, good idea, but I would say refresh. Probably refresh is a better thing, which currently is not available because we should add it. Public void refresh, which we currently do not put in the interface. This is what we do, but what we can now do with this in place, let's do this. If we put this in for the size, the same thing, like this is now size and size. And what we in both things can do, if before position change the value, if not, we return, that's it, and we do nothing. This is a method which we will do protected bool, and we return true by default. So protected virtual bool, which means it could be overridden. So now we give everything that inherits from us the chance to, before we change the size, that it does something to the value. And if it says this value is invalid, then it just returns and does nothing to it. But anyways, what we also can do is this value is a point. And I think, let's see if we can change the value by this. We will see that. So this is before position change. The same should be true for before size change. You will see in a second where this is heading. Before size change, size value. Okay, return true. That is what it is. Refresh is not provided, which I don't know why, but anyways, so this is draw callback, drawing helper, cleanup. So this is not what we're going to do in this case. Okay, so now what we will do is we will hold the window context, which is a window information, window information, and this is, if it's not drawn, nullable. That's great. And then equals now. Then we say, oh, it was window context, I think, underscore. So we will set the window context to this, if it's drawn, the same as private geometry information. This is info. It's null, meaning here, because it is info equals. And then we say take the window context handle, and then we say take your position and your size in. So this is obviously, we cannot know if this is going to happen. Info equals init geometry. What is this? Init geometry with the window context. Here we go. So this must be a method, which must be, we don't know at this point in time if we need to draw a circle, a rectangle, or whatever. So let's do this. This is, now it gets important. Protect abstract method. It needs to be, because it's abstract, it needs to be implemented by the circle, the rectangle, whatever. Here we go. So if we go to the circle, circle is not happy. So we don't do this. We just say base geometry, meaning we need to implement this. And this is how we implement a circle, right? So let's go here. We need the window context handle because, no, we don't need to. So we just need to expose a property which is called handle. Even better, we don't call the window context in a geometry. It takes it. It knows already. So, which means the only thing is private, what was it? In pointer handle equals window context. Question mark handle. This is what it is. So you get the handle, which means you can say, give me, this is not private, this is protected. I'm an idiot. As always, guys, as always, you will see everything protected. So now the circle has a handle, should have a handle. Argument type init is not assignable to an int. Is it an int? Handle is an int, and this is value. Huh? What's going on? Yeah, I know. Dot value. If handle at this point in time equals null, then throw new invalid operation exception. No handle was present. Bad message anyways. So this is the size. Draw a circle. So what we will do is size width here. This is what this actually does. And now we can put in all of this as properties, I think. And this is return this one. It's great. Why is it question mark? I don't want it to be question mark. Init geometry. That's basically it. So now what we should do is, that's great. That's great. So draw callback is a thing. Yeah, that's interesting. What we will do is the draw callback will be something that you could put in the IGeometry. Guys, I'm all over the place, I know, but it needs to be this way. This is prop string, no, action, come on. Prop action of nothing. On draw. That is basically it. And don't make it public. Go to base geometry and say on draw. This is public on draw. Could be virtual. On draw. Never used. And then every time I draw something, I say on draw invoke. If it's on draw, could be nullable. Could be that somebody is not defining the action. I totally get it. IGeometry, make it this way. So now on draw, that's great. So what is my info? So this is like info. No, cleanup window. Info could be, at this point in time, it is not null. Bad code, but you know, I'm assuming it's not null. Clean it up. So the whole thing, all of this is nearly done, guys, nearly done. Because now we have those things which are unmanaged resources and we need to take care about this. This is my last thing for now, but what we can do is we can say this is draw, action, and so on. I know. Position, we will see. We have refresh or redraw, which is not good currently. First of all, it's not in the thing. So let's say void refresh redraws on the geometry, not form. We set geometry, redraws the geometry if needed. There we go. So now we have the base geometry is calling refresh, which is nice. I don't know what's going to happen there, but now we can say inherited doc. So we have properties, we have methods. That is interesting. Protected this, protected this. So, okay, guys, I will make a little break here because I need to go to the bathroom. After the break, I will finish it up, try using this form, and then you understand everything. So bear with me, back in some minutes. Guys, I'm back. Nothing happened here. The chat is quiet, so I'm back. So, okay. Let me quickly finish this up. Base geometry now has everything in place. That's good. Circle is actually drawing a circle. That's nice. Now we need to clean up stuff, right? So what we need to do is we need in the interfaces to tell the IGeometry something, which is it needs to be an IDisposable. So IDisposable is an interface that you urgently need if you are going to have, like me in this case, unmanaged resources. Though what the heck is unmanaged resources? Unmanaged resources are all types that you use that are not managed by the .NET Framework. So not .NET Framework types. And we have a lot of this. Because in our Logic WinAPI, everything we use here, like pointers and I don't know, like all the structs that we're delegating and so on, those are unmanaged resources. So IDisposable is here to say, well, this interface, IGeometry, which is for everything like base geometry, it needs to implement exactly one method, which is... let's do it by hand. Implement members, missing members. This is the only method it expects us to implement. Dispose. Okay, dispose, what is going on? So as you might know, .NET Framework has something which is called a garbage collector. So the garbage collector in principle is there to check constantly if you have certain states in the application where variables that you introduce are no longer needed and can die, can be removed from several stages of memory. So this is very important because this is differentiating .NET Framework, for instance, from C or C++, where you usually don't have stuff like this in place. And this usually poses risks like memory leaks. It's the least important risk because you just lose memory over time. But more importantly, you leave stuff in the memory, which could expose also security risks, right? If you don't clean it up. So in order to handle all of this and in order to talk to the garbage collector and to explain him, hey, you need to do something. You need to inform me if something goes up. What we do is actually we tell it, okay, this gets called by you. I got it. So what we will do is dispose true. This is not existing. This overload does not exist. So what we usually do, we do a protective virtual bool disposing virtual so that clients like children of us, things that inherit from us, can also hook themselves in. That's a good idea. So that is the usual way. We will do this differently. So we do this, dispose, and what we will do is if we will introduce a member variable, which is a bool, which is called disposed, and we will set it to false. And this should be is disposed. So here we go, private bool. So we will say if this is already done, then do just freaking nothing, just return. You will see that in a second. Then we say if disposing. So what is going on? And then blah blah blah. Okay, so this is dispose managed type instances, and this is dispose unmanaged instances. So, and then in the end is disposed is true. So we need those two methods. Let's do this. Create method. This is a protected virtual void. So we give our children and ourselves the chance here to dispose managed instances, types of things. And now we do the same for unmanaged. And here, dispose unmanaged instances, but this would leave the risk that our children override this. So before we do this, we take care of our own stuff. Okay, so this is what we do. Protected. What's going on? Cannot resolve. Dispose. Oh, this is because I renamed it like an idiot. So, and now we take care of drawing helper, cleanup window, and this is getting the, what was it? The info. So what was it? Geometry information, this one. Abstract geometry information, init geometry. This is called like on draw. And then the info thing. This is what it is. I think it needs the info thing. No, it was the, wait a minute. Cleanup window wants a geometry information. Nice. And this is, oh yeah. If info is not null, meaning it was drawn, and only then put it there. So this is what we do. So now we're cleaning up what we beforehand did in one step. That's great. And now we clean it up and we give our children the chance to clean up additional stuff if they need to. Okay, let's clean up this cleaned up. Wait a minute. So that was that. And then maybe we should take care that this is actually protected so that they also can have it. So this is the geometry information. And then we should do it get private set. Does that make sense? I think so. It's a property where we say only we can set it. Our clients can only read it. Oh, it gets even better. So that's pretty cool. That's pretty cool. I think we can omit this. Yeah, you can totally omit this. We don't need this, just returning the field. That gets better and better. Nobody overrides this currently. I know. Protected. What's going on? Can be made private. True. True. Make it private. Even better. Yeah, that's nice. So children can do stuff. We are doing this. Last thing is we need to add a destructor. So a destructor, is there something? Add constructor. Is there something like a destructor? No, there isn't. Well, we would need to do this. This is, I think, protected. Is it this way? I always forget this. Base geometry. And then does this have to be public? Probably. Yeah. Is it? Dispose false. What is this? Oh, it's not public or anything. It's just this way. So this is the destructor. So that explains probably everything. Here we go. And then let's check the circle. This is the main thing. The circle is pretty dumb easy currently. So now we should be able to do the following, guys. Let's check if everything comes together. Here's our concept. And what we will do is var circle is new circle. Let's see. Circle position equals position. And probably it should be a little bit better, like position should be in the constructor, whatever. Anyways, then circle size is size. That's nice. Circle draw on draw equals draw callback. That's nice. Circle draw, and then we do a using And now we do, that's it. That's it. That's all what's left. So the draw callback will just say console retrieve, console right line, circle was drawn, hit any key to exit. That's what it is, read key. And then this is the point, this is the thing. Okay, draw callback. Let's see if it works. It should work, still work. Fingers crossed, guys. Come on. The circle is here. There it is. It waits. Circle is gone. Is program exited? Program is exited. That's it. It worked. This way. It worked, guys. I like my stuff. So now I'm going to explain what I did slowly. Okay. So let's start in the UI. This is our concept. Oh, maybe give me one more second. So maybe what we should do is the geometry should have action. So the callback that gets executed optional, because it's the optional callback that gets executed if the, do we need this callback? Because we draw it? Yeah, we don't need this callback on the, no, we don't need it anymore. Oh, that's actually great. Don't do this, only do this in the concept, which means draw and draw callback invoke. This is an implementation detail which has user input in, so we don't need it in the base. So where's the callback? No. Try. And we will go here. That is it. That is it. On draw can die. This makes no sense. That's good. That's better. Ah, that was very important. So protected can be private. No. It can't, because the clients need it. Potentially, this is where things get out. This is abstract base type for all drawable geometries. That is what it is. La. And then can be overridden by children to define, to react to position changes, to react before position changes, the new value that should be applied, and true if the value should be accepted, otherwise false. It's a constant. Okay, so let's do the same here. Before size changes, the new this is can be overridden to dispose any managed instances. Can be overridden to dispose any unmanaged instances. Be aware. Do not try to dispose the geometry information, because this type already takes care of it. So that's what we put as a remark here. This is in a geometry must be overridden to initialize the actual geometry, drawing it, returns the geometry information. So here we go. Do we have problems with the stream? I'm not sure. Let me refresh this one. What happened? Oh no, all is good. I hope you guys saw everything, because my streaming thing was kind of weird. Are there still people watching? I'm not sure. Anyways, so this is, this could be, oh yeah, this is the internal dispose implementation. Is set to true if it got called by IDispose, which means not called by the destructor. So this is what it means. So disposing means the caller called dispose explicitly, so we can dispose managed types here. So, and this means here, in any case, even if dispose call was missed by caller, and dispose unmanaged types. So the last thing is we need to tell on the normal dispose here, we need to tell GC to press finalize this, I think. So what happens? So we have in principle two ways in IDisposable that the dispose can be triggered. The first way, the controlled way, is if you have something which is IDisposable, you should always call dispose. Okay, that is you should do that on managed types which implement disposable. I did it even so you could say, Alex, you never called dispose. I did because of this. What this means, this is a using, and he wants us to extract this as a using. Let me show you. Convert to the declaration. I highly dislike this. I don't like that, because I think this one is more explicit. It's the same thing, right? But since .NET, I don't, 10, 9, C# 9 or 10 or whatever, you don't need to do it with curly braces. And I want to do it with curly braces because of the simple fact that this way I can clearly see that at this point in time, what this means, if he reaches this curly brace, it will automatically call circle.dispose. This is what this using stands for. It's different from this using. This is just two meanings based on context. Okay, so I call dispose here. Keep that in mind. As soon as I don't need the circle anymore, I destroy every resources. So that means I call this method. This is what I do. Now I redirect this call to this internal private thing that I did. This version never can get called directly by the constructor. It's a private implementation. And I tell here, the suppress finalize says the common language runtime, aka the garbage collector, should not call the finalizer, which is the constructor. Like the destructor, sorry. Where is my destructor? Explicit interface, methods. Where's my destructor. Where is it? Base geometry, method, and then I have this tilde method, dispose here. This is my destructor or finalizer. Let's call it this way so you can see that. So what it means is, hey, garbage collector, don't call this. I took care of it so that we don't double dispose. Okay, so anyways. However, if I would, for some reason, forget to call dispose on any base geometry, it means he will call the destructor in any case. What then I do is I call my dispose method. So the destructor, this is happening if I forgot to call dispose on IDisposable. So I will dispose it, the private dispose, this method, by putting in false. So that way I know this is not happening. So this is now too late to dispose manage resources because I forgot to call dispose. So never mind, don't do this. Just do this. So we ensure that in each scenario with explicit dispose call and without, we are sure that we clean up the window. That is what we do. Okay, so that way I explained to you how this works, right? So, and if we now look into our geometry, now you understand in the WinAPI drawing helper. So we have some usings here as well, as you might saw. So this one, now you understand that I don't like that, right? So let me put the using of the brush here, using var brush. So as you can see, we're using the G, the graphics context, and then we're also using the brush, which means we call dispose here and here. So now we're on the search for more usings, and I hope it still works after I put this in. There were more usings here somewhere. Need to find them. Using here you go. Also the same. So here let's talk about this. I think this is, and I'm not sure, it should be the same as putting in a whole using around this thing. Not sure if it still works, if we dispose or get rid of it. So he's not happy with us. And then what else do we have? Using another one. So now, this is why people don't like it, because you get the snake syntax, right? But I like it, because I see it immediately what's going on. That was it. And now what I will do is, I will tell reshopper, disable on file level this as well. So this is what I'm doing. In this file, please ignore this one. Okay, so now I have it. Let's check if it still works. Okay, Popcorn Gaming. What I'm building is, hey, greetings. So if you want to see that, head over here to my GitHub repository, which is in the description. I'm building OBScene. So OBScene is an OBScene helper. And you can easily look it up here. And if you don't forget to go to the current day 2 branch, which is a branch I'm currently working on, you can see what the goal of the tool is. So that is what I'm building. Hey, nice to have you here. So if you have any further questions, just ask me. I will happily do this. First of all, the thing works. I can remove the circle. Let me repeat this just a second. Is this circle topmost? I think I just recognize that if I put a window up front. Oh no, the circle is topmost. That's great. So it still works, everything. No, I am not going to be paid for this work. This is just my stuff I'm doing. So no, I'm not paid for this. This is just me having fun. And I later will open source this. Yeah. Any other questions? Just come forward. Happily will answer your questions. So, I actually run a company together with my colleagues. So I also own the company, which is this one. You can see what we do in the English one. This is my company website. We don't have a dark mode, by the way. So if you want to, just feel free to go. I will post it here. So this is where I work. And yeah, now you know. Okay, so what did we do? Base, geometry, logic core. Okay, what we did is added core, logic, and more refactoring. Okay, commit. Yeah, commit and push all of it. So I'm not selecting the files. So now if you fetch and pull the day 2 branch, I will merge it today. So you will have it on the main branch as well. That's actually nice. So now what we could do is the following in our concept. So let's see. For later, the demo. Let's see. Var geometries is a new list of IGeometry. Let's see if this works. Now everything comes together. Geometries at this one. Let's see. Position is position. What the heck? Okay, cool. So we will sizes. Okay. Let's do a better new circle. Let's see. This is the easy syntax. Let's do comma here. So we do this. Then we call the drawback. And after the drawback, we need to do for each var geo and geometry, IDispose. So that now you know what's going on. So this is what we do, this is what we do, this is what we do. Yeah. So this is this. And now let's do the following. Let's not do the positions. New point. Let's start at 100. 100. We're not doing this one anymore. So we are pretty close, and the size is going to be var size is new size. Let's say 50 by 50. Okay. So this is 100 by 100. Var offset is, what is that? If it's 50, then it's 100. And then we say that is X. New list geometry. We need to draw them. Geo draw. That's nice. And then we go here. Geo position. Come on. Is new point, which is 1. Okay. So what you need to work on in informatics. So nothing changed there really. You should start by getting the basics, which you can get at my channel and stuff like that. But you should select the language that you want to try to work on, or let's say if you study where you want to test out the concepts, because the concepts in informatics are basically everywhere the same. And then yeah, that's what it is. But it's hard to answer. Offset plus equals what is that? Plus equals, what is that? Radius is this, size dot. Like, for instance, what I'm doing here, right? So just popcorn gaming. So what I'm doing here is just algorithm and data structure. That's what I do. And this is part of the informatics. So you just solve problems. That's what you do. Nowadays, it gets a little bit questionable if you should do this, because you probably are doing the bet against AI, to be honest. But we will see. So let's see if I can. Oh, what happened? I need to concentrate here. Sorry. So demo text row. Yeah. So we now have the size and the points. And now what should happen? We should get demo console write line. That is the callback, action callback, and not even the size. Yeah. We just have the callback. And that is it. Oh, guys, I like that. Circles drawn. So now we should get 3 circles. Let's check if we get 3 circles side by side. I'm not sure. There you are. 3 circles. And they all get disposed. So that is the whole thing, why we did all this things today. So the concept now is pretty clear, right? We don't even need the concept in this case anymore, but it's a clear thing. It's just calling this thing. So we have a size which is 50 by 50, and then we create 3 circles, and then we, for every circle, set its position before we draw it. So we just position by position and draw it. Then we wait for the callback to be invoked, the callback being whatever I pass in here. This is just a so-called action, which takes in no parameter. I'm just waiting here for the read key. So as soon as this callback is done, he goes and disposes all the things, which is the clean way. Okay, so what we did here is we did some concepts from object orientation. So the details on how to draw a circle, how to manage the memory of a circle, and so on, is gone out of our responsibility. So the concept here is, I think, encapsulation. That is the object-oriented concept, which means the type circle encapsulates what it means to provides logic to draw a circle, a topmost circle on the screen, right? So that's what it is. And obviously we have some problems because we need to put this as properties. We will do this in a minute. So circle itself, next thing, now comes inheritance. So we have encapsulation. So circle knows how to deal itself, okay, how to draw itself, how to manage its memory, being disposable. It takes care of all of this. So as a UI programmer, that is the concept here. You don't, if you look in circle, it just provides logic to draw a topmost circle on the screen. That's what I said. So if you look in circle, what circle provides you, it has a size, okay, it has a position, that's it, position and size. It needs to have color, stroke, and so on. That's it. But what it is right now, it's just a circle. You don't know how to handle it, or you can draw it. You can maybe refresh it. I think it's refresh it's called. Yeah, redraws the geometry. So that's all you know. That's all we just expose whatever is here publicly. So the interface controls everything. Size, position, 2 methods, 2 properties, 2 methods. That's it. That's literally what we provide. And you don't need to know as a UI programmer how to do all of this. And that is exactly what we want to reach, right? By the way, thanks guys for your top fan thingies here. Thanks a lot. So now it is, in principle, very easy for us to reuse this. The program just calls this. It doesn't get easier than that. So now let's finalize this by going to the IGeometry, starting here and saying, okay, listen. So what we need is the color, which is that the color from ArcGB? What is it doing? Base geometry. I think we did it. Where do we do is circle? Yeah. This is, the color is red and the color is a struct color. That's nice. So let's do this here. IGeometry takes in 2 things. Color, fill color, get set. color border color get set prop int fill. No, we don't need the fill transparency. The fill color to use, and we will say is color from arcgb, and what we will do is 50 and color red. That's what we do. I think this way or the other way. Color red 50. Is that what it is? Also not true. I know. Color red. So this is 25500. Probably this one. Listen. What is going on? ArcGB has alpha, red, green, blue. All are int. Color, base color. What happened? Color dot red. So this is what I want you. And this is instance property cannot have. Yeah, oh no, because I'm an idiot. This is the interface. I have to do it on the property. The border color to use. You don't need to be afraid. Popcorn, this is do have respect from tasks like this. Look in the end result. I always tell this my customers if I teach them something. You know, fear always is too much. Respect is okay, fear is not. So things like what I do right now. This is, I'm doing it now for, I don't know, 30 years, more than 30 years, more or less. So what I want you to do, however, is to think about dark red, to think about like this is a process, right? So you should not be fearing to be overwhelmed, because you will get overwhelmed pretty fast. Just be sure to do it step by step. Platforms I'm streaming on, only YouTube currently, because yeah, I don't like currently Twitch, like the planning stuff of it. I'm not sure if I can stream in parallel. So I don't want to lose my YouTube community, which I slowly build up. So that's why I'm streaming on YouTube only. Thanks for the questions, by the way. So now I have this color and stuff. So now let's go to my base geometry, last thing, which is the defaults are here. Where's my draw method? Where is my draw? Where is my draw? La la la, confusing the stream. Properties, no good. I think it's, where is my explicit? Yeah, is it here? Oh, where is my draw? Here. Oh, it is in, I think it's here in circle. So yeah, what I should do is color red, not good. This is simply draw a circle. This is fill color and border color. That's what it is. And now this method here was a little bit all over the place, because what it is, it has a transparency. We don't need the transparency. It's only the fill color, and the fill color can define, it's just the fill color. So whatever transparency we need, pen is pen, and we do the stroke color here. Stroke color, and we can add the stroke width later. Now, not sure. Well, we here. So we say border color is nullable, which means it is nullable. Which means, where am I? This also is red by default. This is dark red. Let's move it up. Let's not have a border by default. Red is by default, and then we give it a 50% transparency by default, red. And then what we need is int border width get set, the optional width of the border. This is the optional. So fill color is mandatory. The remaining stuff is optionally. Back? What do you mean with back? Oh, you are back? Welcome back. So yeah, I will show what we have in a second again when we do this. So let's see, this is this base geometry. Now what? Base geometry needs to implement the border width. Right, we have it. So now, by the way, in the circle I want to override before size change, and what I will say, value height equals value width. That's what I want to say. So I want to be sure that value height is the same as width. I'm not sure if this works, but we will see. Okay, let's go, because we say this is a radius, right? Width and height should be the same. Anyways, drawing helper, what else? So now we have the width of the thing. Where is it? Was it in circle? No, it is in draw circle here. And what we should do is radius -1, fill ellipse, if stroke color equal, not now, and stroke width, not now, stroke width, and this is int stroke width. Let's say it's 2 by default, but it could be now. So this is, oh, by the way, it's float, I think, for reasons, because it could be this. Okay, this is stroke width. Okay, what's happening? Oh yeah, stroke width dot value. I mean, stroke width is not now. Now you know. Stroke color, stroke width, new pen. What's going on? This and that? No. What's going on? Stroke color, and then he wants a brush. Oh, no, a color and a width. What's happening? This way. Okay, so this is now stroke width radius minus stroke width value plus 1. Obviously, stroke width value plus 1. Guessing, guys. This is the pen. This is then pen float x, float y. Yes. Float height. Not sure. Okay, I don't care. Should be fine. So now the thing is, can I do mess up stuff? Size is what happens if I say 1000. So this is a stupid size for a circle. So let me put a breakpoint here. And first of all, let's see if it builds still. So what I expect when I hit the breakpoint, and I expect my geometries, which are circles, I want the size of each circle to be 50 by 50. Let's see if this works. So here are my geometries, and the sizes of those are 50 by 1000. So it doesn't work. So interesting. So size is this. Let me see if I hit my breakpoint when I go here. And I say, am I hitting this? Yeah. So value width. So he did this, but this is obviously reference. So it should be ref this, I think, which is another concept that you need to understand. Pass in the thing by ref. So where is it? Let's do this. Before is ref point. Those are value types that why we need to pass them in. And then if we call them, we need to do it here as well. I think that is what it is. And this should fix the problem. Let's check it out. Now we have 2 breakpoints. Oh, where is it? Where's my second? Oh, I probably have to before ref value here. Okay, you always have to add ref if you say add the reference. Okay, let's see. So we have this. What about the geometries? The sizes are 50 by 50. So now what my circle does is, let me show you my circle type. So if I have this override here, which gets called by the base type, if I go here, so what this does, just to explain it, class design in .NET. So it gets a value which is 50 by 1000, which is stupid because it could be valid for rectangle, but not for circle. So what the circle does, it overrides, so it does something different than the parent, the before size change. The parent class, which is the base geometry up there, gives the circle, which inherits from it, the option to, hey, if you want to do stuff different before I change the size, you can do it here. So what I do is I set the height equal to the width. So the width is my leading thing on a circle. So no matter what you do, the width is the radius. And by doing this, even if you try, you cannot give me a stupid circle. So there are circles, like the radius always is the same, but I want this to be like, if you check the size, it should be like symmetrical. Width and height should be the same because that's what it is. The bounding rectangle always is a quadratic one. Okay, so this is done. I can control the color. Let's see if that works in the concept. I can say var. Let's do it here. On the middle circle, let's say I want the fill color to be color from RGB. Let's do an 80% blue, right? Blue. So now I should have 3 circles. The middle one should be blue and 2 reds. So is it working? It totally is. Red, blue, red, right? So this is exactly what we want to achieve, guys. Okay, so we have full control now. And then obviously I could say, well, this one on the other side should have a border color, which is color yellow, just like that. That's the easiest part because I don't define any alpha. Let's execute this without debugging. So here we go. Now we have different forms. So I can do whatever I want. So that is nice. So this was the hard way to not call dispose, and it should have still disposed everything. So I like that a lot. I like that a lot. I do. Pretty proud of myself. Edit color properties and circle handling. This is pretty good. Commit and push. So that's all we need to know. I think that's it. So we have 3 logics. Those logics are referenced. So basically all that's left, I don't need the WinAPI anymore. I can remove this project reference. All I need is a core logic. That's it. I don't even need this anymore, I think, because it is brought in. I can clean it up. Let's see. Thank you. Rebuild. So here we go. Now let's try it again without debugging. It works. So I even can run it from my console, just to be clear, right? So if I go to source, bin, come on, source, no, this is UI, bin, Windows, debug.NET 10, and then it should be no. Where is it? Oh, it's not obscene exe, it's obscene UI test console exe. There are my circles here on my screen. And if I hit enter, they disappear. Let's do it again. Those are my circles. I don't know. Can you see that, guys? I hope so. I hope you can see this. Yeah, and this is what obscene is going to be, right? So back here, this is what we want to reach, right? I could even do a rectangle big as my screen. This comes later, but I'm here right now, right? I'm here at this point in time. I start a process. I get this overlay, which should be at exactly the location. Let me see if I can draw this for you. Can I? Yeah, at this location here, this is my plan. So that all of this here, you can see my mouse, you can't. So, and I can do that because you will not see this red circle if I position it exactly above this area. Where is it? So I will position it exactly where this circle is right now, here. I will do that because it's in my OBS, right? So, and then that's going to be it. I have it then. And so let's look back here, what we wanted to achieve. This was my architecture. Nice. Let's do this a little bit. What was it? Let's do this bigger. I'm not sure. Like this, something. Okay, so, okay. What was the plan? Code cleanup, we did it. OOP, of course. Explanations, I did that. Class design, interfaces, and so on. Storing, no, we don't store scenes yet. Reacting to OBS screen, no, of course not. This needs to be in the next part. Something like that. Day 3. But we did this here. So we did this day 1, link in the description, we did this, and I think it's a great thing. So now last thing is, I'm going to merge. Let me see, do I have something open? Yeah, I have. So this is removed unneeded references, commit and push. So what I can do now is I merge locally because I don't need a pull request, right? Gmain git merge day 2. There you go. I will push this. Here we go. I will clear my local branches. There we go. So that means now main branch should be clean. If I go here and I go main, I should see everything that I saw. That's great. And now I'm good. I should be able to just remove day 2. 2 branches. I don't need a pull request. Day 2. What? Rename? No. Can I? Oh, here. Delete the branch. Here we go. And you're good, guys. You're good to go. So you have everything in your main, what you need. You should be able to get it down, follow the instructions, .NET build or whatever, and then that's it. So, guys, I think that's it. What do you think? I think it was a nice demo. It was fun. We're pretty close to have a usable thing. I literally could use it right now. Just position the thing, run the exe, just put it out, and then I would see whatever I wanted. It's a bad design right now, so I want a notification area icon. I want to react on OBS scenes. If I switch the scene, it should switch with me and stuff like that. This will get interesting. So we get some logic OBS. And let's see how this works. This is where we actually next time probably need to work on. To retrieve the OBS scenes, and I'm not sure. Let me look up something. I have a backup of my OBS. Let me open this folder. Yeah, I have a backup of OBS here. So you know what I'm thinking about? I don't know if I open. Let's do a sneak preview for next time. This is my OBS backup. There's nothing here. Service. Okay. Format document. So here we go. That gives me nothing. this is just my YouTube stuff. And probably that was a bad idea. I need to change my YouTube key. So I will regenerate my key so that you guys cannot stream on my... I need to do this immediately after I did this recording. Yeah, and then what else? I was thinking that, you know, on OBS, I'm thinking of the layout of my stuff, where my windows are. There should be some information on that. I will see. So anyways, I gave myself something to work on, like securing my YouTube channel now. And yeah, I will do that in a second. And I think that's it for now. I will end the stream here. Once again, thanks for participating. A lot of stuff went on. Thanks for putting in all this stuff, like the top chats and so on. I like that. I'd love to see you next time. Give me some feedback, maybe, if you want me to do something different, if I need to talk more about stuff, whatever. But other than that, see you next time. I stop the stream now. Have a great day.